All right, Geometry Geniuses, we're back. Going to close out this first section talking about postulates. We'll also talk about accepted facts of geometry that don't need too much of an explanation, that I think just kind of makes sense. And that's really what a postulate is. It's an accepted statement of fact, a big deal in geometry where there's no need to prove it. It's just accepted, it's known, it's the norm. And that's what the postulates are. They're just accepted facts with no need to logically figure it out. But we use these to show that other things and other happenings in geometry make sense. So the postulates are really the ground foundation of just common things that we know. One being that if we have 2 points, there is exactly one line that will go between them. In this example seen here, points A and B are on line T. Line T is the only line that's going to pass through this. So you could think of this in the sense that if you have school, so let's say that O'Hara looks like this, it kind of whips around. Now it just looks like someone who's strong and has muscles. You see that with arms. If we have O'Hara on one block and then, well, let's see what's across the way. And you have the cemetery on another block. So let's say the cemetery is over here across the street. There's only going to be one street that encompasses these 2 buildings. The cemetery is here, O'Hara is here. This is one unique road, which is sprawl, if I recall correctly. So that's your real world way to think of it. There's only one street that's going to have these 2 buildings on it in Springfield. And we take this further and say that the intersection can occur if we have 2 or more geometric figures where they hit each other, and that's where the common ground is where they intersect. 2 more postulates that are helpful. If you're a fan of copying down and having everything, go for it. The first postulate here says that if 2 distinct lines intersect, then they intersect at exactly 1 point. So if these 2 lines A and E and D and B intersect, there's only one intersection, which in this case would be point C. Another postulate says that if we have 2 distinct planes intersect, when they intersect, there's one line that shows that. Although this is a 3-dimensional drawing, I've drawn this out here. So you can think of it like this. You could think that the plain colored post-it note is one plane, and this darker post-it note cuts through it. And there's only going to be the one line that intersects it, seen here. So this tape's kind of overbearing with it, but this line seen here is the only line that's going to intersect. So this is kind of making it more 3-dimensional. We see that this is one plane that's dark, the other is green, solid green, and they have the one line that intersects between the 2 planes. Kind of cool way to think of it. And so we'll see this with examples. So we have this cube here that's made up of several planes. This can be a little difficult to decipher or to visualize it. So drawing these out will always help, or thinking of another example that you've seen in the real world helps as well. So each surface of the box at the right represents part of a plane. What is the intersection of plane ADE and EFG? Well, let's find ADE. ADE is this plane right here. H is also on the plane, but we don't need that at the moment, just because they didn't mention it in the labeling. EFG is this bottom plane seen here. So now this kind of looks like a chair. So sometimes these geometric figures will throw me off. So I try to separate them so I can see a little bit of a better picture. So I have A, D, E, then H, and I also have F and G. So what line is intersecting these 2 planes? Hopefully you're saying E and H. So E and H is intersecting the two planes. Or if you want to get fancy, we have line HE intersecting. This is taking it further. Which two planes intersect in EF? Well, let's see. Where's EF? EF is going from the left to the right, just like this. The two planes that are intersecting there. One plane is definitely going to be ABF. So we have plane ABF. And what's the other plane? If ABF is kind of taking the forefront, what's this bottom plane that creates the intersection? You could call it HEF if you want. That works just fine. What else? Another postulate. Through any three non-collinear points, there is exactly one plane. Points Q, R, and S. So Q, R, and S are non-collinear. They're not on a straight line. Plane P is the only plane that contains them. That makes sense. These points are kind of all over the place. They're not in a straight line. So there's only one plane that's going to have all of them together, and that's plane P. That makes sense. 3 more examples, and then you're done with this first section. What plane contains points E, F, and G? Shade the plane. I see E, F, and G here. So the plane that's going to encompass this is going to be a mix of, well, I mean, you can mix this up in a few different ways. You could say E, F, G. That's actually easy because they give you the points and they're on the outside realm. So we could do that. What plane contains points A, B, and H? Well, let's see. This one's a little tricky because A to B is definitely here, and H is all the way down here. So this actually requires us to create a plane that shows what's going on there. So you can think of this now as like a slice of cheese. Or a hunk of cheese, like in the cartoons, how they have that large cheese block. This can be A, this is B, this is H, this is G. Yeah, and you actually might want to see that. So that's what I'm talking about. All right. So what plane contains A, B, and H? You could say it's this one. We'll shade it also. It's kind of going diagonal. Again, there's no line or set easy plane to spot. This cuts through the figure here. So you could say that that's going to be, yeah, just like that, ABH. Again, you could also call it some other ways. You could say BGH, you could do HAB, GHA. You have a few options there. What's the name of a line that is coplanar with EF and EH? So recall, coplanar means that they're on the same plane. So let's find E to F. E to F is going from here to here. E to H is going from here to here. So we're looking for a plane that contains these two lines. So it's really this bottom layer here that we're focusing on. Notice how I'm rewriting this or sketching this out again. I'm using up paper to draw this to get a better look on what's going on. That's definitely a good look. Oh, interesting. I don't need that. Sorry if that was up for a bit. So I redrew the plane that had EF and EH seen here. I'm looking for another line that is coplanar with these. You have a few options. I mean, you already talked about this, and you already talked about this. You can do H to G. So line H to G works. F to G also works. So at the end of this, we've talked about a lot of vocab. We've talked about basic points like point C. We talked about lines. We talked about rays that have two endpoints, or sorry, we talked about segments that have two endpoints. We talked about rays that have an endpoint, another point, and then takes over everything else on the line. We talked about planes. We talked about the intersection of them. So there was a lot of visual stuff here. So from here on out, you should be able to use the basic geometric vocabulary. Where I see students trip up is with the idea of the line, the segment, and the ray. And we'll also be using those postulates throughout the year, so get familiar. If you have any questions, let me know. If you would benefit from looking back at the previous videos, go for it. I'll make those links posted. And you can always shoot me an email if you're stuck on anything. Thanks for watching.